Hello, hello, mic testing. Hello, 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 hello. Okay, I hope mic is now working good. Let's start the session, students. Hello, hi everyone. In the last session, we have discussed some definite integrals and what is definite integrals, formula for definite integrals, and how to apply definite integrals for finding values of definite integral. In this session, we will discuss the properties of definite integrals and then solve few problems for that. Okay. Now we will discuss the properties of definite integrals. Properties of definite integrals. The first property is integral a to b f of x dx is equal to minus integral of b to a f of x dx. Now if we change the limits, upper limit become lower limit become upper limit, then this integral value will be negated. That is the first property. I will again repeat. The first property is if we change the upper and lower limit of the integral, then the integral value will get negated. That is the first property. Okay. Now let's see the proof for this property. Let integral f of x dx equal to capital F of x plus c. Then by the virtue of definite integral, if we apply the limit a to b, f of x dx is equal to, here we got f of x plus c, between the limits a to b, we have to apply the limits, that is f of b minus f of a. Okay. Now this can be written as minus of f of a minus f of b, because f of b is some value. Similarly, f of a gives some value. We have solved few problems for this. So we already know what is the value, how to find the value of definite integral. So this is some value. We can write this f of b minus f of a as minus of f of a minus f of b. Then we will get, this is nothing but change the value limit. Then this is f of a comes here, b comes here, and a comes to the upper limit. So that is f of a, capital F of a minus capital F of b, the value of this integral. So final answer is minus of integral b to a. That is, we have to change the limit. As first we will apply the upper limit, that is capital F of a minus lower limit, capital F of b. So this is the first property. Second property is we can break the integral into different intervals. We can find the value of the integral, given integral, into different integrals. I will explain this property in a very small way. Here what is this a, b, c? Let's assume some function. For understanding this property, let's assume some curve. Let this be some f of x, small f of x. Let this be curve f of x. Next, what we will do is take some value a, b, c. Let this be point A. Let this be B. And let this be C. Okay. Now we have got A, B, and C. This A to B integral is divided into here A to C plus C to B. Now A to C can be written as, by this diagram, this total area can be represented by two areas. That is the first area plus second area. As we already know, what is definite integral? It gives the net area of the function. That means we can write this integral of, first we will have A to C, A to C f of x dx, that can be written as integral of a to b f of x dx. What is this value? It gives the area of the function. This is area function. So this region, this is, let this be a1. So this is a1 for us, plus integral of b to c, second area, that is f of x dx. This is a2, second area, and this is a2. Now that means the total area between a to c can be written as integral a to b f of x plus integral b to c f of x. Now suppose if we change the limit by first property, then what will we get? If we change the limit a to b, c to b, then these two will get changed. That means we will have to subtract the area from the total area to get the remaining area. That is the meaning. From this statement, we can again observe that this area a to b is a1. Let the total area be a. A to c is the total area, that is a plus a1 plus a2. And c to b, that is nothing but minus of a2, because we already learned if we interchange the limits b to c, integral b to c f of x is nothing but minus of integral c to b. So we can write this as minus of integral b to c f of x. That means we have to subtract this area a2. So this total area is a1 is equal to a1 plus a2 minus a2. That is true. That is this property. So what we are trying to say is, by observation, we can write any integral between two values can be split into different intervals. We can add the areas by consecutive areas, or we can also subtract some areas from the total area to get the resultant area. Answer will be same. Right? This is the second property. And we can extend this to n intervals. We can easily observe, suppose there is another point D. Let the area between C and D be A3. Then integral A to D will be integral A to B f of x plus integral B to C f of x plus integral C to D f of x. A1 plus A2 plus A3. That is this property. Okay. Now let's see the proof. First is, let's take this integral f of x equal to capital F of x. Now what is right hand side? Integral a to c f of x plus integral c to b f of x. Actually what we are doing is just take this upper and lower limits which are not in this. This c will get cancelled. This is the easiest way to remember this. So here we will get f of c minus f of a. For the second integral we will get, when you apply limit, f of b minus f of c. F of c will get cancelled. This is nothing but f of b minus f of a. That is integral a to b f of x. That is left hand side. Easy proof. So this is integral a to b f of x. Next is integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Again, proof is very easy. What we are actually doing in this, integral 0 to a f of x is equal to, limit remains the same. Here inside the function we are replacing x by add both upper and lower limit minus of x. That is the answer. So how we are doing this? Let's observe. Let's take this a minus x, t equal to a minus x. Wait a moment. Let's change the color. Okay. Let t equal to a minus x. Now what we need to do? Replace this right hand side. We will take right hand side first. T equal to a minus x. Now t equal x equal to 0 means, x is equal to 0 means integral variable is, variable of integration is x. So we will substitute x equal to 0, lower limit, then t becomes 0, a minus 0, that is a. Second, let x is equal to upper limit is a, then t will be equal to a minus a, that is 0, which means we can write right hand side as, let's take this I, right hand side, this is equal to integral of, we are converting this a minus x as t, so we will get f of t, and what are the limits? A to 0 dt, dt is minus of dx, dt is minus dx, so here we will get minus dt. Again we can interchange the limit, that is equal to integral of 0 to a by first property, integral 0 to a f of t dt, f of t dt. And what is integral 0 to a f of t? This is nothing but we can change the variable, we have already seen the theorem. So this is equal to integral 0 to a f of x dx, as t is a dummy variable. That means this is equal to left hand side. So that is the proof. Easy. What we are going to do, take this a minus x, whichever is in the right hand side, take this as t. By substitution we are proving this property. Clear na? Easy proof. What we are doing, take this a minus x as t and solve the right hand side. When we simplify this integral, we will get the left hand side automatically. That is it. So what this property means, in place of whatever limit is there, add these two values minus x. That is this property. Okay. Now let's see the proof. It is same. Proof is take a minus x as t. So dx will be minus dt. And we have to find the integral limit. That will be t values when we substitute t equal to a minus x. And then right hand side integral will become integral of 0 to a f of t dt. That is, here we will change the limit, so it will become a to 0 minus of. That is it. So this will be converted to 0 to a f of t dt, which is integral 0 to a f of x dx. Hence this is the proof. Okay, next is fourth property is same as third property. Here we have some other number instead of 0. In third property we had 0 to a integral. Here we have a to b f of x dx. Again it is same. What we are going to do, add these two limits, upper and lower limit, minus of x. That is it. Proof is similar to the previous one. You can take this a plus b minus x as t and then substitute. We will get the same. So let's see the proof directly. Let a plus b minus x is equal to t. So minus dx will be minus dt. Sorry, minus dx will be dt. Or dx equal to minus dt. Now when x is equal to a and b, what are the values of t? T will become, a will get cancelled here, t equal to b. For the second case, t equal to a. So that means limit will become, this integral will become integral b to a minus of f of t dt. That is integral of a to b f of t dt. That is the left hand side, as we can change the variable of integration. Again, proof is similar to the third one. You can try by yourself for this. Next property is integral minus a to a f of x dx is equal to 2 times integral 0 to a f of x dx if f of x is even, otherwise it is 0. F of x is odd means the value is 0. Now what is the condition of even and odd functions? For even functions, f of x equal to f of minus x. For odd function, f of minus x equal to minus of f of x. That is the even and odd function definitions. We already learned this in functions. Okay. Now we have to prove this. Integral minus a to a f of x dx equal to 2 times integral 0 to a f of x dx. Proof is actually very easy. What we are going to do, take this minus a to a f of x dx and split into two integrals. One is minus a to 0 and 0 to a. Let's do the proof for this. Okay. integral minus a to a f of x dx is equal to integral minus a to a f of x dx is equal to integral of minus a to 0 f of x dx f of x dx plus integral of 0 to a f of x dx. Okay, now what we need to prove? If f of x is even, that means when f of x is even, f of x is even, that means that is f of minus x is equal to f of x. F of minus x is equal to f of x. Okay, now this value will become 2 times integral 0 to a f of x. We already have 0 to a f of x. That means this value should become integral 0 to a f of x. Now what we will do is take this minus x as t. We can replace this as, let's take this value as I1. This is case 1. I1 will become, let's take minus x as t, minus x equal to t. That means we will get, when x is equal to, here dx will be minus dt. Okay, when x is equal to minus a, x equal to minus a implies what is the value of t? T will be a. And when x is equal to 0, t will be 0. That means what are the integral? This I1 will become, which means I1 will become integral of, lower limit is a to 0 f of minus t, because t is minus x, so here we'll get x is equal to minus t, f of minus t into dx will be minus dt, so minus of dt. Now this is equal to integral of, we can change the limit, that is 0 to a f of minus t dt, and this is nothing but integral of 0 to x f of x minus x dx. Now as f of minus x is equal to f of x, that means we will get, this is nothing but integral 0 to a f of x dx. Since f of minus x equal to f of x. Now the proof for this second case is also same. Instead of f of minus x equal to f of x, we will substitute f of minus x is equal to minus of f of x. Then what will we get? When f of minus x is equal to minus of f of x, then we will get this value as minus integral 0 to a f of x. That means this total integral will become, this is minus some value plus some value. Both will get cancelled out. Answer will be 0. That is the proof for this. And for the first one, we get this I1 as this value integral 0 to a f of x. Second integral is also same. That means we are adding the integral 2 times. So 2 into integral f of x dx. Proof is done. Easy. So proof for these functions is very easy actually, and you can expect questions on proof from the definite integral in your boards. So this is again very easy. What we are substituting? Substitute x is equal to minus t or minus x is equal to t. Okay. Now change the variable of integration as well as change the limit into the variable we choose. Then we get this value integral 0 to a f of minus x dx, and then based on if f of x is even, this is f of minus x is equal to f of x, so we will get some value, that is integral 0 to a f of x dx, which is the same as the second value. Similarly we can do for the next one. So first case is for even function we get 2 times integral 0 to a f of x dx. For the second one, if f of x is odd, proof is similar. Here we will get f of minus x is minus of f of x. That is it. So these two will get cancelled out. Minus integral 0 to a f of x dx plus integral 0 to a f of x dx. Both will get cancelled. So final answer will be 0 when f of x is odd. This is the proof for this property. Next one is integral 0 to 2a f of x dx is equal to 2 times of integral 0 to a f of x dx. Integral 0 to 2a f of x dx is equal to 2 times of integral 0 to a f of x dx. Again, this is applicable when f of 2a minus x is equal to f of x. Proof is similar to the previous property. Now what we are going to do is, in the previous case, we are taking an interval about origin. It is a mirror about origin. Here, about y-axis, we can take y-axis when function is even, it is about y-axis. When a function is odd, it is about origin, mirror about origin. For this case, we will consider function from 0 to some value. Let that value be 2a. Now this value will be equal to, this is a function that is symmetrical. If it is symmetrical about the line x equal to a, then we will get this property. That is geometrical representation of what this integral mean. Right? Okay. For now, these are not required for you. We will just go through the proof for this. Again by using substitution property. Now what we will do for this is, again break the integral 0 to 2a as integral 0 to a f of x plus integral a to 2a f of x. This is the property. We will discuss the proof for this. We can write this integral as, let's change the color. We will write this integral as integral of 0 to a f of x dx plus integral of a to 2a f of x dx. Next, what we are going to do is substitute t equal to 2a minus x. Substitute in this integral. Let this be I1. Let's keep this integral as it is. I is equal to, let's keep this integral as it is. So what we are going to do is, for I1, let's substitute t is equal to 2a minus x. Then what is dt? dt will be minus of dx, or dx equal to minus dt. Next what we will do? Change the integral limit. Then substitute when x is equal to a, t will be equal to 2a minus x, that is 2a minus a is a. When x is equal to 2a, t will be 2a minus 2a, that is 0. That means integral I1 will become, that is equal to integral of dx will be minus of dt, so we'll get minus of dt. Then integral limit will be, when x equal to a, answer is a. When x is equal to 2a, answer becomes 0. Then f of, what is the value? 2a minus x is t. So how to write this? X is equal to 2a minus t. So f of 2a minus t. dt. Now this can be written as, change the limit, then we will get integral of between 0 to a f of 2a minus t dt. Again this is equal to integral of 0 to a f of 2a minus x dx. We already know this. So from this we can observe that this I1 is integral 0 to 2a f of 2a minus x, and here we get the next value is integral 0 to a f of x. We already got this value, integral 0 to a f of x dx. Here we get the second part is I1 will become integral 0 to a f of 2a minus x dx. So that means what is the value of I? I is equal to integral of 0 to a f of x dx plus integral of 0 to a f of 2a minus x dx. Now the proof is very easy to see. If f of x is equal to f of 2a minus x, That means this value will become f of x. So this integral I will become 2 times integral 0 to a f of x. That is the proof for first case. What about if f of x equal to f of minus f of x equal to f of 2a minus x? Then this value will be minus of integral 0 to a f of x. That means when we add these two, it will become 0. That is the proof for second. So this is the easiest way to prove this by substitution. Okay. Proof is, you can do it yourself. Just observe this and it is very easy. Case 1 is we have to split this into two integrals and replace f of 2a minus x equal to f of x and substitute t equal to 2a minus x before. Similarly, solve for next case. If 2a minus x equal to minus f of x, then we will get the value 0. Yes. Once you do the first condition, and from that we can differentiate into different cases and then solve this. Okay, next one is similarly the next proof. We can go to the questions now. One of the interesting question in indefinite integrals, this type of question can be difficult to solve, but for definite integrals, the applications of properties play a very important role. Here the question is integral between 0 to pi by 2, integral between 0 to pi by 2, sin power 5x divided by sin power 5x plus cos power 5x. Okay. Now what we are going to do is, we already know the property integral 0 to a f of x dx. Here f of x is this value. This entire value is f of x. We already know the property integral of 0 to a f of x dx, f of x dx, that is equal to integral of 0 to a, limit remains same, f of a minus x dx, a minus x dx. This is a very important property, students. And when to apply this type of properties? We will apply these properties by observing that when we change this f of x into f of a minus x or f of a plus b minus x, for both these properties I am telling, then when we add these two, that is the critical step. It is not just about changing f of x equal to f of a minus x. We have to add the given question, that is integral, and we change the integral. When we add these two, the integral will become much more simplified, or it will become a constant, or it will convert into a standard form which we can integrate easily. These three conditions will be applied. So when we use this type of property, we will use this when we have this condition that when we add the integral with the changed integral, the function will become simplified and it becomes easy to integrate, or it becomes just a constant. So in those cases, we will apply this integral. Now by observation, here we have sine and cos. In the denominator, we have sine and cos both. Now here limit is between 0 to pi by 2. That means 0 plus pi by 2 minus x, that is pi by 2 minus x. That is nothing but 90 minus theta. Sin 90 minus theta is cos theta. Cos 90 minus theta is sin theta. That means by observation itself, we can see that when we change f of x, x as 90 minus x, then we will get denominator same, and in numerator, sin will become cos. Then when we add these two, as denominator is same, we will get sin plus cos. Easy to see. Now let's see the proof for this first case, and after this we can do it by just observation itself. It is very easy. Now what we will do first is use this property. That means if this is I, then we will get I is equal to integral of 0 to pi by 2, integral 0 to pi by 2, sin power 5 of pi by 2 minus x, pi by 2 minus x, divided by sin power 5 of pi by 2 minus x plus cos power 5 of 5 pi by 2 minus x. Now this is sin 90 minus x power 5, that is equal to integral of 0 to pi by 2 cos power 5 of x divided by, again we will get cos power 5 of x plus sin power 5 of x. Okay, now let's take this function given question as 1 and this as 2. Actually both are same integral. That means we can write this as integral is equal to, after 1 plus 2, when we are adding these two, integral will become I plus I, that is 2i, that is equal to, as denominator is same in the both, we can add the numerator, then we will get sin power 5x plus cos power 5x divided by sin power 5x plus cos power 5x dx. Limit is between 0 to pi by 2. Okay, now this numerator and denominator will get cancelled. This is nothing but integral of dx, which is x. This is very, very easy to integrate now, and limit is between 0 to pi by 2. The value is 2 times I. So this is nothing but pi by 2. As 2i is equal to pi by 2, what is the value of integral? I is equal to pi by 4. That is it. It is easy to evaluate, much more simpler now. What we did? Use this property. F of x integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Okay, that is it. Now we will see the solution. Most questions will be based on these properties from definite integral. So you should be very, very thorough with this. Now sin power 5x integral 0 to pi by 2 sin by sin plus cos power 5. Let this be 1. We will use this property integral 0 to a f of x equal to a minus x f of a minus x. Then this will become in numerator cos, denominator will be same as the question. So when we add these two, that is the critical step. Always we have to add for such properties. When we add these two, we will get numerator and denominator gets cancelled, and this is nothing but integral of dx. So that is nothing but x, and apply the limit, which is pi by 2. So 2i is equal to pi by 2 means I is equal to pi by 4. That is it. Next is integral between 0 to 4 modulus 2 minus x dx. Okay, another easy question. Modulus 2 minus x dx. The first step is, whenever we have functions of this type, we have to first identify if the function is continuous or if the function changes its nature or definition at a certain point within the interval. What do I mean by this? First, let's take this as f of x equal to, let me have this as f of x equal to, let this be f of x. Now this f of x can be defined as, as with this 2 minus x. When this 2 minus x is greater than 0, that means 2 is greater than x. 2 minus x is greater than 0 means 2 is greater than x, or x is less than 2. So whenever x is less than 2, we get this value as positive number. That means the same value applies. Then mod x will be minus x when x is negative. That means when 2 minus x is negative, that is the other region, x is greater than 0, we have to change the sign. Then it will become x minus 2. This is the value of the function. Function definition is changing like this. So that means first we have to observe this change. Then what we need to do, see the interval that is between 0 to 4 we have to calculate, and 2 is a point inside the value 0 to 4. That means we have to define this interval split this integral into two separate integrals first. So what we need to do is I will be equal to integral of, first write 0 to 2 as this function changes its nature at the point 2. So now what we need to do is integral 0 to 2, between 0 to 2 function value is 2 minus x dx. Next, plus integral of, from 2 to 4, what is the value? X minus 2 dx. That is it. Now we evaluate this integral. Now this is nothing but 2x minus x square by 2 between the limits 0 to 2 plus x square by 2 minus 2x between the limits 2 to 4. Now apply the limits. And don't forget, sir, here also function is same, looking same, but only limits is changing. So can we add this directly? Don't make such mistakes. Always these two should be evaluated separately. Now this is equal to, when we apply the limit, for lower limit, first value is 0, 2 into 0, 0 square by 2, that is 0. For the upper limit, we will get 2 into 2 is 4, minus 4 minus 2 square is 4 by 2, that is 4. So, sorry, 2. So, we will get 4 minus 2 for the first integral. For the second integral limit, then we will have 4 square by 2, that is 8, minus of 2 into 4, that is 8, minus of, we will have 2 square by 2, that is 2, minus 2 into 2, that is 4. Now the total is 4 minus 2, 2, plus this value is 0, 2 minus 4 is minus 2, minus of minus 2 will be 2. So final answer is 4. This is our required answer. Clear now students? Easy? Now let's see the solution. Always remember, whenever we have modulus, whenever we have a break in the function which is not a smooth curve, or whenever function has a sharp point, or whenever the function is not differentiable at a point, then we need to evaluate carefully. Based on the integral interval, that is the limits, we have to see if the function has a smooth curve or any sharp points, if the function is differentiable or not. In those points, we have to evaluate the integral. Now this is, let I is equal to this value. Then first step is identify the function nature and split into two integrals. That is between 0 to 2 modulus plus between 2 to 4 mod 2 minus x dx. Now this is equal to, this mod 2 minus x is as it is between 0 to 2 and this changes its sign between 2 to 4. So this is our, after integration, this is our value result. Now apply the limits. Easy. So final answer is 4. Next question. From here on we will try to solve little faster. Between 0 to pi, integral x by 1 plus sin x dx. Okay, sir. Now what we need to do? Apply the property. This is integral of between 0 to pi. We can write this as f of x dx integral is f of a minus x dx. So we can write this as integral 0 to pi minus x by 1 plus sin of pi minus x dx. What is sin pi minus x? Sin 180 minus theta is sin theta itself. So denominator is same. And in numerator, we can split this into two integrals. So if this is I, then we will have I is equal to integral between 0 to pi divided by 1 plus sin x dx minus x divided by 1 plus sin x. X divided by 1 plus sin x is nothing but I, integral of 0 to pi x divided by 1 plus sin x dx. Now why do we need to apply this property in the first place? when you observe the question, here in numerator we have x, in denominator we have 1 plus sin x. We don't know the integration for this. But when we apply this property, here numerator will get simplified as this term is also I. As this term is also I. So this implies we will get 2i is equal to integral of between 0 to pi divided by 1 plus sin x dx. Okay. Now if the function gets simplified by application of this property, now what we need to do? This integral 2i is equal to, pi is common, we can take it outside constant, then integral of 0 to pi, here we have 1 by 1 plus sin x, we can multiply and divide by 1 minus sin x, then we can write this integral as 1 minus sin x by, here in denominator we will have 1 plus sin x into 1 minus sin x, that is 1 minus sin square x, 1 minus sin square x. And what is 1 minus sin square x? 1 minus sin square x is cos square x. That means we can split this integral into again two separate integrals, that is pi into integral of, this will be integral of 1 by cos square is secant square x minus, here in numerator we have sin x, in denominator cos square x. Sin by cos is tan, 1 by cos is secant. So this becomes secant x tan x dx into dx. Now limit is between 0 to pi. Okay sir. Now how to evaluate this? This is equal to pi times of, we already know the integral secant, that is tan x. Integral secant is tan x minus of integral secant x tan x, that is secant x. Integral secant x tan x is secant x. Limit is between 0 to pi. Now it is easy, we just need to apply the values. This is equal to pi times of, for tan x, tan pi is 0, tan 0 is also 0, minus of secant pi is minus 1, so it will be plus 1, minus secant 0 is again 1, so we will have minus of this value, minus will become plus here, again secant 0 is 1, so we will have 2, that means 2i is equal to 2 pi, which means I is equal to pi. That is it, easy. Question will look a bit lengthy and difficult, but it is actually very easy. How do we say that? First we have to identify the problem and choose which property we need to apply. Here in this question we have the integral between 0 to pi x by this value. Our purpose of using the property is to simplify the given question into standard form. By using this property f of x dx, integral 0 to a f of x dx equal to integral 0 to a f of a minus x dx, we simplify this question first. And then we choose to apply the property, and then this becomes a standard integral which we can easily manipulate to find the answer. Okay. So we will first use the property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Then this integral will become this and split into two separate integrals. The second integral is nothing but the integral itself. So we will get, when we take it to left hand side, we will get 2 times I is equal to pi is constant into multiply and divide by 1 minus sin x. Little bit manipulation to get the standard form of integral. So we can just apply the limits after integration. Easy. Final answer comes out to be I is equal to pi. Okay, next is integral between 0 to pi by 4 log of 1 plus tan x dx. Again, easy question. We have to understand when to use which property. Here integral is between 0 to pi by 4 log of 1 plus tan of this value. Now we'll apply this property, integral between 0 to a f of x equal to integral between 0 to a f of a minus x dx. That means I integral will become integral of 0 to pi by 4 log of 1 plus tan of pi by 4 minus x dx, pi by 4 minus x dx. Okay, sir. Next, what we need to do? This is I. Okay. Now just apply the property tan of a minus b is equal to tan a minus tan b divided by 1 plus tan a tan b. That means we will get integral between 0 to pi by 4, integral between 0 to pi by 4. Okay, integral between 0 to pi by 4 log of 1 plus, this is tan pi by 4 minus tan x, tan pi by 4 is 1 minus tan x divided by 1 plus tan pi by 4, that is 1 into tan x. Okay, sir. Now just cross multiply into dx. Now we will get integral between 0 to pi by 4 log of, this value is 1 plus tan x plus 1 minus tan x, that is 2, plus tan x minus tan x will get cancelled, minus of this value 1 plus tan x divided by 1 plus tan x divided by 1 plus tan x. This will be plus tan x minus tan x, so it will get cancelled out into dx. Now we can write by using the property log a by b is equal to log a minus log b. That means we will get integral between 0 to pi by 4 log of a, that is 2, minus log of b, that is 1 plus tan x dx. Now what is this integral? Log of 1 plus tan x, which is nothing but the question. So we will get this I is equal to integral 0 to pi by 4, integral of 0 to pi by 4 log 2 dx minus again the same integral. That means 2i is equal to, integral 0 to pi by 4 log 2 dx. Now log 2 is a constant, that means this is equal to log 2 into, when we integrate dx, answer is x. Now apply the limit, that is between 0 to pi by 4, which is nothing but pi by 4 log 2. And what is this? 2 times I. Always remember what we are doing. We are adding this. So we have 2 times I. So that means I will be equal to pi by 8 log 2. This is a very, very important question, students. You can surely expect your one question based on this property, as well as you can expect the same question also in your board exam. So you should remember this property. Use the application of this by using the virtue of this property. We will solve this question by just using f of a minus x is equal to integral 0 to a f of x dx. So we will solve this. This is a very, very important question. You can expect as a subjective question for 3 mark, 4 mark questions in your board exam, as well as for competitive exams like JEE mains. You may need to remember the direct result of this. Okay, let's see the solution. What we are going to do? First, replace f of x as f of a minus x within the integral and simplify this. That is log 2 minus of log 1 plus tan x. This is again I. So we have 2i is equal to log 2 integral 0 to pi by 4 dx. That is nothing but 2i is equal to log 2 into pi by 4. That means I is equal to pi by 8 log 2. Okay. This question, can you try yourself? Very easy question. It is similar to the previous question we have discussed, the first problem we have solved. In the first problem we had sine power 5x divided by sine power 5x plus sine power cos x. Here we have root of sine x. Again procedure is same, and the limit in the previous problem is 0 to pi by 2. Here limit is pi by 3 to pi by 6 to pi by 3. Okay. Now what is pi by 6? 30 degree. Pi by 3 is 60 degree. So we have the property integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. We will see the solution. It is very easy. You can try these questions yourself. So this is integral a to b f of a plus b minus x dx. And also remember, when you observe this type of property application, here we have this entire term vanishing. F of x completely vanish when we add. When that happens, the answer will just be, we have to subtract these two limits divided by 2. That is the answer. For objective questions, for MCQs, you can remember the result like this. In your board exam, one more question can be asked based on this, as well as in competitive exam, you can directly answer within seconds. So what is the property? Integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. Now by virtue of this property, we have, when we add these two limits, we get 90 degree, and sin 90 minus theta is cos theta. So in numerator, when we have the change in this angle into a plus b minus x, we will have cos x. In denominator, we will have root cos x plus root sin x. So denominator remain unchanged. And now when we add these two, this is the question. Add the question with the, after the application of property, what we get. Then the answer, final answer comes out to be integral dx. Because these two will get cancelled out, as denominator is same, we can add the numerator. These two are same values. So after cancellation, we get 2i is equal to x when we apply the limit pi by 6 and pi by 3. That is pi by 3 minus pi by 6. This will always be true for any question. What is the observation we made? Whenever we add the two functions, after changing once and before changing once, question plus after application of property, when we add these two, when the entire function vanishes, then the answer will just be subtract upper limit minus lower limit divided by 2. That is the answer for this type of problems. So what is the final answer? Pi by 3 minus pi by 6, that is pi by 6 divided by 2. Pi by 12. We can answer with this type of questions within seconds. It wouldn't even take 5 seconds to observe this. Next question is similar to few problems before we solved. In the problem before, we had x divided by 1 plus sin x. In this problem, we have x sin x divided by 1 plus sin x. And the limit is between 0 to pi. Okay. Solution is similar to the previous. We will use the same property. Just we can go through the solution now. Here we have I is equal to integral 0 to pi x sin x divided by 1 plus sin x. Now we will apply the property. What is the property? Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Now after application, we have sin pi minus x divided by 1 plus sin pi minus x. Okay, sin 180 minus theta is sin theta. So we will have pi minus x sin theta sin x divided by 1 plus sin x. Now when we split this into two separate integrals, this pi sin x divided by 1 minus sin x, 1 plus sin x is one part, and another part is x sin x by 1 plus sin x. That is the question. So that means we can split this into two separate integrals, and this part is nothing but the question itself. So that means 2i will be equal to sin x divided by 1 plus sin x dx. 2i is equal to pi into sin 1 plus, that is sin x divided by 1 plus sin x dx. Now what we need to do is try to manipulate this expression. So we get the answer. How to integrate this? Here in denominator we have 1 plus sin x. So what we will do is add and subtract 1 in the numerator. Then this 1 plus sin x term will get cancelled in the first integral. That will be integral dx, which is x. Second integral is minus of integral 1 by 1 plus sin x. We have solved this question already. What we did? Take the conjugate 1 minus sin x, multiply and divide in numerator and denominator. We will get 1 minus sin x by cos square x. Procedure is same, easy. So we get first term becomes cancelled out, that is integral dx. Second term is 1 by 1 plus sin x. So 2i is equal to pi into x minus, again second integral is multiply and divide by 1 minus sin x. So first integral becomes pi into, after integration this is x, apply the limit, again we will get pi, so this will be pi square minus of pi into, here we have, this is secant square x, integration is tan x, second one is secant x, tan x minus secant x in the interval 0 to pi. So that is pi square minus pi into tan x minus secant x in the interval 0 to pi. Apply the limits. Pi square minus pi into tan pi is 0. Secant pi, cos pi is minus 1. So secant pi is also minus 1. Minus second again tan 0, secant 0. Tan 0 is 0, secant 0 is 1. Minus into minus will become plus. So final answer is pi square minus 2 pi divided by 2. That is the value of I. Again another question. This is also similar to the previous. Properties. We just need to use the properties. And by practicing more and more problems, you will understand eventually when to use which property and when should we use properties to solve. That is the key part in this. Okay, now this is cos x divided by 1 plus e power x dx. Now what we will do is, this is of the form between integral between minus a to a. That is, again we can use the same property. See, if it is odd function or even function, we can use that property, or we can also use f of a to b, integral a to b, f of x equal to integral a to b, f of a plus b minus x. Both properties are actually same. In this, when we add these two, answer is 0 minus x, that is again minus x. So what we will get is, this integral is equal to integral of between minus pi by 2 to pi by 2. Here we have cos of minus x divided by 1 plus e power minus x dx. Okay, next what we need to do, what is e power minus x? E power minus x is nothing but 1 by e power x. That means when we take LCM, we will get integral between minus pi by 2 to pi by 2, integral between minus pi by 2 to pi by 2, cos of minus x is cos x, cos of minus x is cos x, divided by e power x plus 1. When we take LCM, we will get e power x plus 1 divided by e power x, that will go to the numerator, dx. Okay, now this is the question 1 and this is 2. Let this be I. When we add these two, 1 plus 2 implies we will get 2i, that is equal to integral between minus pi by 2 to pi by 2. Denominator is same in both, numerator is cos x and e power x cos x. That means 1 plus e power x into cos x divided by 1 plus e power x dx. Now these two will get cancelled. The function becomes very simple to integrate. Integral of cos x. What is the value? Sin x. So that is sin x. Limit is between minus pi by 2 to pi by 2. Okay, what is the value of this? Again, sin pi by 2 is 1 minus of minus 1, that is 2. 2i is equal to 2 implies, what is the value of I, students? I is equal to 1. Finish. So solution is First we will do this and then use the property integral a to b f of x dx is equal to integral a to b f of a plus b minus x. Here minus pi by 2 to pi by 2 means we will get, these two will get cancelled out. So minus of x. So cos minus x divided by 1 plus cos e power minus x. Cos of minus x is cos x. This value will become e power x plus 1 divided by e power x. That is e power x will go to the numerator. So e power x into cos x divided by e power x plus 1. Now what we need to do? Add these two. Then 2i will become 1 plus e power x will get cancelled in numerator and denominator into cos x. So this is nothing but integral of cos x dx, which is sin x, and apply the limit. This value is 2i. So 2i is equal to 2. What is the value of i? I is equal to 1. Easy. Next question is integral between minus pi to pi x power 6 sin x dx. Now if this is f of x, we can easily answer these types of questions. These are all 1 mark questions. Let's change the color. Okay. What we have is product of two functions. One is x power 6, another is sin x. If we have to integrate this, we have to use integration by parts, and then we have to do that 6 times and then apply the limit, which is very lengthy. Then what we can do is try to use the properties of definite integration. Here this is nothing but take this function as f of x. Take this function as f of x. Now integral f of minus x will be equal to minus x power 6, that is x power 6, into sine of minus x, sine of minus x. What is sine minus x? Minus sine x. So this is minus x power 6 into sine x, which is nothing but minus of f of x. So what is the property we got? F of minus x is equal to f of minus f of x, which means f of x is odd function. F of x is odd function. Okay, when f of x is odd function, integral between minus a to a f of x dx will be 0. We already know the property. Just use this property. How to solve this? First use this. Integral is between minus a to a. That means first step we should think of is see if this function is odd or even. If it is odd, then answer is 0. If it is even, 2 times integral 0 to a f of x. Easy. We got 4 options. What is the answer? Answer is 0 as this function is odd. Next is minus 1 to 1. Again this integral is also in the form of integral minus a to a. That means again we have to use this property log of 3 plus x by 3 minus x. Now when we substitute x is equal to minus x, denominator goes to numerator and numerator becomes denominator. What is log a by b? Log a minus log b. That means answer will be 0 as f of minus x is equal to minus f of x. So what is the answer? Correct option should be option D, 0. Easy. We can just see the question and answer this. 1 mark questions, simple questions. Again integral is between minus a to a. Integral of the type minus a to a, minus pi by 2 to pi by 2 log of. This question is same as previous question. Here we have theta as the variable of integration. So we have to substitute in place of theta minus theta. Then sine of minus theta is minus sine theta. So numerator is 2 plus sine theta. Denominator becomes 2 minus sine theta, which is again reciprocal of this, which means again this is a negative. So log f of minus x is minus f of x. That means it is an odd function. So answer should be 0. Option A. Easy questions. With this we have completed integrations. We have seen definite integration, indefinite integration, formulas for integration, and how to find standard integrals and use of standard integrals in solving integral values. Also we have seen method of substitution, partial fraction, how to integrate rational function, integrals of the form denominator differentiation is there in the numerator, or some linear function, some other linear function is there in the numerator divided by denominator. So types, we have covered almost all types that are required for your boards. So this is very important topic, integration, and we have seen everything related to indefinite integration as well as definite integration. In definite integration, we have discussed how to find the value of definite integral and properties of definite integrals and use of properties, applications of properties for solving problems. Okay students, with this we have completed this session, and keep revising, always keep learning and keep growing. Success is yours, line by line. Endigu namma tapasya. Thank you students. In the next class we will start other chapter. Thank you.